Welcome to Telumen Insights, where we reveal the hidden forces that shape the way you live and show you how to use them to create real transformation and supercharge your health, mindset, and daily life. Here are your hosts, Emma Greenwood and Nathan Sinclair.
Welcome back to Teolumen Insights. You know, every now and then we come across something that just completely shifts our perspective, and today is definitely one of those days. We're diving headfirst into the work of Dr. Chris McGinty, and specifically, his McGinty Equation.
Ah, yes, the MEQ. It's been making waves, hasn't it?
It certainly has, and for good reason. We're talking about potential breakthroughs that sound like they're straight out of science fiction.
Faster than light travel, quantum teleportation.
Limitless energy, even. But before we get lost in the sci-fi possibilities, let's start with the basics. What exactly is the MEQ?
Well, in essence, it's a theoretical framework that attempts to bridge two seemingly very different worlds: quantum mechanics and fractal geometry.
Okay, so we're talking about the very small, the realm of atoms and particles.
And the infinitely repeating patterns of fractal geometry. Dr. McGinty's work suggests there's a deep connection between these two, a hidden link that could unlock some incredible possibilities.
It's a bold idea, to say the least. But how does that translate to these futuristic concepts like faster than light travel? That's something that's always captured the imagination, but it seems to defy the laws of physics as we understand them.
Exactly. And that's what makes the MEQ so intriguing. It challenges some of our fundamental assumptions about the universe, particularly Einstein's theory of relativity.
Which says nothing can travel faster than light.
Precisely. But Dr. McGinty proposes that by manipulating gravity, we might be able to warp space-time itself, essentially creating shortcuts that could allow for faster-than-light travel.
Warping space-time. That sounds like something out of Star Trek. But how would that even work in practice?
Well, one of the key equations within the MEQ is T equals C over G squared.
Okay, break that down for us.
So T represents time, C is the speed of light, which is a constant, and G is the gravitational constant. What this equation implies is that as gravitational forces increase, time actually slows down.
So the stronger the gravity, the slower time moves.
Exactly. Imagine a spacecraft that could generate an intense gravitational field around itself. For the crew inside, time would slow down relative to everyone back on Earth.
They'd be time traveling as well as space traveling.
In a sense, yes. And this time dilation effect could make it possible to travel vast distances across the cosmos in a much shorter amount of subjective time.
Shorter for the astronauts, but what about for the rest of us back on Earth?
That's one of the mind-boggling aspects of time dilation. It's all relative. But even with time dilation, traveling across the vast distances between stars would still take a very long time, wouldn't it?
Right, even if it's shorter for the people on board the ship, which is where I'm guessing wormholes come in.
You got it. Wormholes are theoretical tunnels through spacetime, and they're another concept the MEQ explores. Imagine folding a piece of paper in half and poking a hole through it.
Shortcut.
Exactly. Wormholes could potentially connect distant points in the universe, allowing us to bypass the vast distances of space altogether. And the MEQ suggests that fractal geometry might play a key role in creating and stabilizing these wormholes.
Okay, now my head is really spinning. Fractals. How do they fit into all of this?
Think of fractal geometry as the architecture of the universe. The MEQ proposes that the fractal dimension of spacetime could determine the size and stability of wormholes.
So the higher the fractal dimension, the larger and more stable the wormhole.
Precisely. It's like finding the right blueprint to build a stable bridge across the universe.
But stabilizing wormholes, that still sounds incredibly theoretical.
It is. We're talking about cutting-edge theoretical physics here. But what's exciting is that researchers are already exploring these concepts through simulations and even looking for observational evidence in space.
Yeah.
It's early days, but the very fact that we're having these conversations is, well,
mind-blowing to say the least.
Exactly. And the implications go far beyond just faster than light travel. The MEQ also touches on another mind-boggling concept: quantum teleportation.
Oh, wow. The idea of teleporting objects or even people instantaneously. Is that something the MEQ actually suggests is possible?
The MEQ hints that we could potentially revolutionize quantum teleportation. It all boils down to a phenomenon called entanglement, where two particles become linked no matter how far apart they are. Changing one instantly affects the other, almost like magic.
Like two sides of the same coin, even if they're light years apart.
A perfect analogy. And the MEQ could provide a framework for understanding and manipulating this entanglement, leading to advancements in secure communication, advanced computing. Even teleportation might be within reach.
From bending space-time to teleporting objects, it's clear the MEQ is pushing the boundaries of what we've thought was possible. But before we get too carried away with all these incredible possibilities, let's take a step back and consider the practicalities. We're talking about harnessing forces that are beyond anything we've ever encountered.
Absolutely, and that's where things get really challenging. But even if some of these applications are still a long way off, the MEQ is already forcing us to re-examine our assumptions about the universe and our place in it.
To think bigger, to imagine the impossible.
Exactly. And that, in itself, is a remarkable achievement.
It certainly is. And on that note, we'll take a quick break. When we come back, we'll delve deeper into the potential applications of the MEQ, from limitless energy to revolutionizing medicine, and even understanding consciousness itself. Stay with us. Welcome back to Teolumen Insights. We're deep in the world of the MEQ, exploring its potential to rewrite the rules of reality as we know it. Before the break, we were talking about faster-than-light travel and quantum teleportation, but there's another potential application that's just as mind-blowing. Limitless energy.
Ah, yes, the holy grail of energy research. And the MEQ might just hold the key to unlocking it.
So we're talking about solving the global energy crisis, transitioning away from fossil fuels. Is that something the MEQ actually suggests is possible?
What's fascinating is that the MEQ connects to ideas like cold fusion and zero-point energy. You see, even in a perfect vacuum, there's still a tiny amount of energy present at the quantum level.
Zero-point energy. I've heard of that, but it always seemed like something purely theoretical.
It was considered fringe science for a long time, but the MEQ provides a framework for understanding how we might actually tap into this energy source. Imagine harnessing the energy of the quantum vacuum, a virtually limitless supply.
No more fossil fuels.
Yeah.
No more dependence on finite resources. It sounds too good to be true.
It's definitely a paradigm shift, and the technological hurdles are immense. But the MEQ offers a tantalizing glimpse into a future where energy scarcity is a thing of the past.
It would revolutionize our world. But how does the MEQ actually propose we tap into this zero-point energy?
It involves manipulating gravity in very precise ways. The MEQ gives us equations that relate temporal energy, the energy woven into the fabric of space-time itself, to other factors. And by understanding these relationships, we might be able to develop technologies that draw energy directly from the quantum vacuum.
That's incredible.
Yeah.
But if we're talking about manipulating gravity, creating wormholes, teleporting objects, wouldn't we need immense computing power to even begin to design these technologies?
You're absolutely right. That's where AI comes in, specifically AI holographic quantum computing.
Now, that sounds like something straight out of a science fiction movie.
It might sound futuristic, but it's a field that's rapidly advancing. Imagine using AI to design and control quantum systems, to run complex simulations based on the MEQ, to optimize these incredible technologies.
So AI is like the key that unlocks the full potential of the MEQ.
Exactly. AI could help us design the tools, analyze the data, and accelerate the development of everything from faster-than-light spacecraft to quantum teleportation devices.
It's a powerful combination. But with all this talk of limitless energy and bending the laws of physics, it's hard not to feel a little overwhelmed. Are there any downsides we should be considering?
That's a crucial point. We need to approach all of this with a healthy dose of caution and critical thinking. The potential benefits of the MEQ are huge, but there are also potential risks that we need to address.
Like what? What are some of the things that could go wrong?
Well, for one, imagine the implications of technologies like faster-than-light travel or limitless energy falling into the wrong hands. We need to carefully consider the ethical implications of these advancements and ensure they are used responsibly.
It's a lot of responsibility.
It is. And there's also the question of unintended consequences. Whenever we tinker with the fundamental laws of nature, there's always the possibility that we'll unleash something we didn't anticipate.
Like opening Pandora's box.
Precisely. We need to proceed with caution, to carefully consider the potential risks and benefits, and to engage in open and honest discussions about the future we're creating.
So it's not just about the science, it's about the ethics, the philosophy. It's about who we are as a species and what kind of future we want to build.
Absolutely. The MEQ is a mirror reflecting our values, our dreams, and our fears. It's a reminder that scientific progress is not just about equations and discoveries, it's about making choices, taking responsibility, and shaping the world we want to live in.
Well said. And on that note, let's shift gears a bit and delve into some of the more specific concepts within the MEQ. We've been talking about these mind-boggling ideas, but I'd love to get a better understanding of the math and the science behind it all.
Of course. Let's unpack some of those equations and explore the theoretical underpinnings of the MEQ in more detail. Where would you like to start?
Well, we've been talking about manipulating time and gravity. Can we start with that?
Sure. One of the most intriguing equations in the MEQ is T equals C over G squared. It basically tells us that time and gravity are intimately connected.
We touched on this earlier, but could you remind us how that works?
As the gravitational force increases, time actually slows down. Think of it like a cosmic speed limit. The stronger the gravity, the slower time moves.
So near a black hole, where gravity is incredibly strong, time would move much slower than here on Earth.
Exactly. And this phenomenon, known as time dilation, is a key prediction of Einstein's theory of general relativity, and it's been experimentally verified many times. The MEQ takes this a step further, suggesting that we might be able to artificially manipulate gravity to induce time dilation.
Wow. So we're not just talking about observing time dilation, but actually controlling it.
That's the idea. It might sound like science fiction, but the MEQ provides a theoretical framework for how we might actually achieve this, and the implications are staggering.
I can only imagine. What about that other equation you mentioned earlier, the one about temporal energy? How does that factor into all of this?
Ah, yes, that's another crucial piece of the puzzle. The equation at equals am times c over pi times g squared relates temporal energy, which is essentially the energy woven into the very fabric of space-time, to mass, the speed of light, and the gravitational constant.
And what does this equation tell us?
It suggests that by manipulating gravity, we could potentially tap into this temporal energy, perhaps even using it to power our spacecraft or other technologies.
So we're not just talking about bending time and space, we're talking about harnessing the energy of space-time itself.
Exactly, and that's just the tip of the iceberg. The MEQ offers a whole new way of looking at the universe, a new set of tools for understanding and potentially manipulating reality itself.
It's mind-boggling, but let's talk about something a little more concrete. We keep coming back to wormholes. Can you explain how the MEQ suggests we might be able to create and stabilize these theoretical tunnels through space-time?
One of the key concepts here is fractal geometry. The MEQ suggests that the fractal dimension of spacetime could be the key to stabilizing wormholes, making them large and stable enough for a spacecraft to travel through.
So it's like finding the right blueprint, the right geometric configuration to create a stable wormhole.
Exactly. And what's exciting is that researchers are already exploring ways to simulate these conditions in the lab. They're using advanced materials and techniques to try to create mini wormholes just to see if the principles of the MEQ hold true.
Many wormholes in the lab. That's incredible. And what about quantum teleportation? You mentioned that the MEQ could revolutionize this technology. How so?
The key to quantum teleportation is a phenomenon called entanglement. Two particles become linked in such a way that they share the same fate, no matter how far apart they are.
So if you change one particle, the other one changes instantaneously, even if they're on opposite sides of the universe.
Exactly. It's like they're connected by an invisible thread. And the MEQ could provide a deeper understanding of how this entanglement works. It could also help us develop technologies that harness entanglement for communication, computing, and even teleportation.
That's amazing. But what about the practical challenges? How far away are we from actually being able to teleport objects or even people?
Well, we've already been able to teleport photons, which are particles of light, across considerable distances, and researchers are working on teleporting larger and more complex particles.
It's incredible to think that we're even having this conversation. But as we delve deeper into the MEQ and its potential, it's important to remember that there are ethical considerations as well.
You're absolutely right. With any powerful technology, there's the potential for misuse. We need to think carefully about the ethical implications of the MEQ and ensure that these technologies are developed and used responsibly.
It's a lot to consider, but it's also incredibly exciting to think about the possibilities that the MEQ opens up.
I agree. It's a journey into the unknown, a quest to understand the deepest secrets of the universe and our place within it. And who knows where it will lead us. But one thing is for sure, it's a journey worth taking.
It certainly is. And on that note, we'll take a quick break. When we come back, we'll explore the philosophical implications of the MEQ, and we'll discuss what it all means for the future of humanity. Stay with us. Welcome back to Teolumen Insights. You know, it's amazing to think that we've only just scratched the surface of the MEQ and its implications.
I know, right? It's such a rich and complex theory. It feels like we could talk about it for hours.
Absolutely. But I think we've covered a lot of ground today. We've talked about faster than light travel, quantum teleportation, limitless energy. It's a lot to take in.
It really is. And what's so fascinating is that it's not just about the science itself, but about what it means for humanity.
Right. It's about the choices we make, the future we create. It's almost philosophical, isn't it?
It is. The MEQ forces us to confront some fundamental questions about our place in the universe. If we have the power to manipulate time, space, and energy, what does that mean for our understanding of reality?
That's a deep question. And it's one that I don't think we can answer definitively right now, but it's a question that we need to be asking ourselves.
Exactly. The MEQ isn't just a set of equations. It's a challenge to our worldview, to our understanding of what's possible.
And a reminder that we're not just passive observers. We have the power to shape the future, to use this knowledge for good or for ill.
Exactly. And that's why it's so important to have these conversations, to consider the ethical implications of these technologies.
To think about the long-term consequences of our actions.
Precisely. We need to be careful, but also bold. We need to approach the MEQ with a sense of wonder, but also with a sense of responsibility.
Well said. And with that in mind, I think it's time to wrap up this incredible deep dive into the MEQ.
It's been a fascinating journey.
It really has. And we want to thank you, our listeners, for joining us on this exploration.
We hope it sparked your curiosity and inspired you to think about the possibilities that lie ahead.
Because the future is not predetermined. It's up to us to shape it. This is Teolumen Insights, signing off.